Can you, so
like, how do you distinguish when it's multiplication on the outside of parentheses or when it's like addition?
it'll be really, I'm just going to say, it's going to be really obvious. It's got to be. So if I have my parentheses, what do you want to put in the parentheses? You make it. What do you want in here? Doesn't matter.
6 plus 7.
6 plus 7. I like it. So if I have this, what is that operation?
That's multiplication. Right.
And if I mean addition, I better freaking put a plus sign in there.
Okay.
You see what I mean? If I mean subtraction, I better put a subtraction sign in there. You see what I'm saying?
So do you still multiply with the addition and
So here, this is 3 separate problems, right?
Yes.
Yeah.
All right. So definitely, what would you do here first?
Multiply for sure.
6 plus 7.
There are two. There are two things you could do, but officially, if you follow order operations, 6 and 7 is 13. Twice 13 is 26. I like it. It would still work if you did this, but that's sort of like a little extra work.
All right.
Here, what's this? 2 plus
Whatever that is,
13, which is? There's a plus sign.
Basically, the sign is in between the parentheses and the thing.
Yes, tells you that. So we know when it's sitting next to it, we know that really means multiplying.
Right.
Any other explicit sign means that. Yes. So where people really mess up
That's where I get from.
is this. That's not right. Something's gone horribly wrong here. And some of you guys are like, what do you mean? Negative 3 squared is positive 9.
Because they added the positive sign.
What's the operation now?
It's a multiplication.
And what did it become?
Addition.
All right, again, that's Hogwarts level shit, right? That's points to Gryffindor. But it's got to stay multiplication. It better stay multiplication.
Okay.
That is 9, but it's multiplying by 2.
Okay, cool, yeah. Because my brain just keeps telling me, like, whatever is on the outside. Multiply.
Oh, I see.
Now I get it. Thank you. Need clarification.
All right, good.
So it's not negative 9 because you got 3 negatives, they cancel each other out.
Yeah, 2 negatives, yeah.
Or I mean, yeah,
And they kill each other. Yeah.
2, not 3, 2.
How is it different if it were inside? I forget with the exponent. If
Uh,
the 2 were in the parentheses.
Well, you mean just looking at this versus this here, right?
Yeah, well, if the exponent was in the parentheses,
Oh, well, that's really this.
that's just that.
Yeah. So watch, guys. Just to do this again.
Real quick, what if you had a 3 instead of a 2? Then would it cross?
Oh, a 3 up here?
Yeah.
Well, then you do negative 3 times negative 3 times negative 3. 2 negatives cancel, so the answer would be negative
Negative 9. No.
27. Because now you got 3 3s if you put a 3 up here, right?
Right.
3 times 3 times 3 is 27.
27.
Negative, because the negative's still alive. I like it. Yeah, just watched Jim Frankenstein again the other day.
Oh, trust me, I did. Like,
Yes. Oh, wait, I'm sorry. Real quick, I'm sorry. Do you see how these parentheses are completely unnecessary?
Yeah.
There's nothing in front. There's nothing up here. So these parentheses are like not necessary. But the question was, if there's a 2 outside or a 2 inside, what's the difference? There's a huge difference. This is 3 squared
Then you carry the
with a negative sign in front of it. So what's 3 squared? 9. And then put a negative in front of it. What's this one? This is 2 whats? 2 negative 3's multiplying. What's negative 3 times negative 3?
9.
Positive 9. I like it. So again, if you want to look at this one really odd, it would be negative sign and 2 3's. Is there no negative to kill him?
No.
Nope. So he's still alive. Here it's 2 negative 3's. Is there another negative to kill him? Yes. So it's positive 9 at the end. Don't make a big deal out of that. I know that a big deal has been made already amongst all students everywhere in the universe, but yes.
For iPhone, right? It uses 6 times 2 is 12, right?
Yeah, it'll still work. 2 times 6 is 12. 2 times 7 is 14. 12 plus 14 is? Yes, because distributive property is true. Period. But just to show you a kind of extreme example, if I said what's 18 times 897 minus 895. Do you want to do this? Okay. I'd rather do 18 times 2. Yeah, shit, yeah. This would still work, but my God. Well, what is 897 minus 895?
A freaking lot.
2. Oh, never mind. I get what you're saying. You're just confusing me. You're way too confusing.
That's super easy.
Okay.
Never
No, what helps a lot. What helps a lot is to pay attention.
It's to not smoke crack.
Not carry on your own conversation and pay attention. That normally helps. I don't know. It's just a little public service announcement. Yeah. Okay. But no, this is why we have several teachers teaching the same class, because different styles work better with different students.
No, this is good. I'm just.
No, it's okay. You can have your opinion. It's fine. But if you need me to explain something a different way, I can obviously do that. That's part of my job. Right? So, again, what's happening here always? Order operations. And what do you always do first? Parentheses. Now, real quick, just because of what I just said, real quick, go with me for a second. Here, can I do inside the parentheses first? I can't remember if I've done this with you guys yet or not. You ready? You ready? Come on. Come on. I can't do inside. What is x minus 1? I don't know. Freaking Crayola. Crayon? I don't know what that x minus. Is it happy face? I don't know what that is. Now, stay with me. Stay with me. So a really good question is, all right, Jeff, you can't do parentheses first, so why can you do anything? Why are you allowed to do this shit? That should be your question. I make such a big deal out of PEMDAS, and then here I'm like, oh, we can't do that. Let's do this instead. Screw group PEMDAS. All right. So you should be upset if I haven't I can't remember if I showed you this or not. So when I can't apply PEMDAS directly, I try to rewrite the problem so I can reorganize it. So what does 4x mean? Do not say 4 times x. It means 4x is doing what? We just had this earlier. X plus x plus x. Okay. You with me?
Yeah.
So what does 4m mean? M plus m, blah, blah. So what does 4 of these mean? This plus this plus this. Go with me now. So how many x's do I have?
4.
4 of them. Now I'm just combining like terms, right?
Yep.
4x, and then I got negative 1 minus 1 minus 1 minus 1? Minus 4. So the shortcut then is the distributive property. The distributive property is just a shortcut. I'm not breaking the rules of PEMDAS. I'm rewriting the problem so then I can do like terms. So that's why it will still work here if I do distribution, but dear God, I don't want to. Yes, ma'am. Sorry, yes. Alright, guys. In which section? 3, 3?
Yeah.
Okay. I like that, yes. 3, 3. Okay. 207? Oh, 3, 4 then. No, where's 207? Oh. What's it say? Is that a long thing? Let me see.
No, remains on an alpine height. The temperature is -7 degrees. The net sleeping bag is rated comfortable to -20 degrees. How much can the temperature change before it's too cold for the net sleeping bag?
Oh, okay. Step outside of math for a second.
Yeah.
How much could the temperature go down and you're still comfortable in your sleeping bag if it's okay to -20 degrees? Really what you're saying is how far away from uncomfortable are you? You're at -7 right now. The bag is okay to -20. The minute it hits -21, the bag goes, oh, screw it. And it just lets all the cold air in. How far away am I from this? 13. How far is 7 from 20?
At -.
What's happening? So if I said, if it's negative 7 degrees outside right now, how many degrees must it drop by before it's negative 10 degrees? 3 degrees. Is that cool? I know they're both negative, but that's actually kind of cool. They're on the same side of the number line. I can just see how far apart they are directly. When they're all positive, it's easy. When they're all negative, it's actually just as easy, to be honest. So how far apart are negative 7 and negative 20? They're 13 degrees apart. So how far should the temperature drop? 13 degrees. Yeah. So you could apply math to this, but it's actually a problem. Just you can step outside of math for a second and say, 13 more degrees and then I'm screwed. Maybe. Where it gets weird is if it was currently like 3 degrees. This isn't too weird. And it was okay at negative 20. How far could the temperature drop and you're still okay? How far would it drop just to get to 0?
3.
And then from 0 to this is how far? 3 and 20, 23 degrees. You could drop 23. So it would be like 3 minus negative 20. That's the math you would actually be doing. So that's where you have to bring it in. When you're on opposite sides of the number line, things get a little bit weird.
You gotta go back to the point first and then...
Go back to the origin first, and that's actually a way you can apply to a lot of problems. How far away from the 0 am I, and then how much further do I go? So like if I said negative 14 plus 17, how far away from 0 is this? 14. So if I add 14 to it, I'm at 0. How much more am I adding? That's why this is 3, because I go 3 past 0. You can apply that same thinking to that kind of problem too.
I know.
All right, I like it. Now, if I ever give you multiple ways of looking at a problem, and there's a way that I tell you that you dislike, don't look at it that way. Right? I don't know, you guys. I don't think you look at math correctly. Math is not. This is the way to look at it. Math is, here's an idea. There are 18 ways to look at this idea and have it still work. So this is what I mean when I say make math your own. You come up with your own way of looking at it, and it's probably a valid way to look at it. All right. Maybe?
Yeah, I like that.
Okay. All right. Okay, so where do we want to go from there? I think did I skip somebody over? Yes. Yes. So you guys remind me, very quickly, 2 is easy, right? To see if 2 goes into something. How do you tell if 2 goes into something? It's even, right? How about 3? Who remembers that?
They are
Not if it's odd. 3 doesn't go into 7.
if they add
If all the digits
add
to
a number divisible by 3.
Good. A multiple of 3. I like it. All digits must add to a multiple of 3. What's that? Okay. So like the number 114, is that divisible by 3? What's 1 plus 1 plus 4?
6, yes.
Is that divisible by 3?
Yes.
Okay. So 3 goes into 114.
It's good.
3 also goes into this number, because notice I'm picking nothing but multiples of 3. So if you add all that stuff up, it's going to be a multiple of 3. So 3 will go into a higher number. That's kind of crazy. But it should work that way. Tell me multiples of 3. 3, 6, 9, 12. There's a nice pattern to those, so there should be a pattern to see how it goes in. The only one that doesn't have a nice pattern really in the first 10 digits is 7. Poor little 7 dude. Right? He gets to be the lucky number, right? But he's unlucky when it comes to divisibility. He's like, I don't have a clue what the hell 7 goes into. I just got to figure it out. What about 4? The last 2 digits have to be divisible by 4. So for example, 2,748, does 4 go into that?
Yeah.
Yes, because the last 2 digits are divisible by 4. Stupid. What about 5? That's easy. And then 0, 5. Okay. What about 6? What's 6 break it up?
Oh, 2 and 3.
So it's got to be even, and all the digits have to add the multiple. Do you guys see? If 2 goes in, because it's even, and 3 goes in, because all the digits add to a multiple of 3, then 6 must go in. Just let that be, make sense. If I can cut it in 2 and cut it in 3, I can cut it in 6. That's what that means. I love it. And I think the book 2 and 3, blah, blah, blah. And then 10, I think, is the last one they do in the book, right?
5 or 10.
10's got to end in 0. What? I think I told you about 9. 9 is similar to 3. If you add up all the digits and is a multiple of 9, then 9 goes into it. But I don't think this book uses 9 as something. Yeah. For a little book. All right. So, when I give you, if I give you this number, is it even? Is it even? Is this an even number? No. So 2 does not go in. 3 goes in because it adds up to a multiple of 3. Does 4 go in? Does 4 go into this? Does 4 go into the last 2 digits? Hell no. So 4 does not go into the number. Does 5 go in?
No.
Hell no. But see, on the homework, you better tell me 3 goes in because it adds up to whatever. 4 does not go in because it doesn't go into 93. 5 doesn't go in, it doesn't end in 0, 5. 6 doesn't go in because freaking 2 doesn't go in. You got to tell me each one why or why not. Great philosopher. Googly mooglies. Great googly moogly. So that's what it means when he says apply the divisibility rules. You better show me what you're doing. All right. Show me the math. All right, where are we going to go from there? What's the number?
75.
75? Well, all right, does 2 go into it? Why? It's not even. Does 3 go into it? Because 7 plus 5 is? Which is a multiple of 3. Do you guys see that? Alright, so 2, no, not even. 3, yes. 7 plus 5 equals 12, multiple of 3. 4. There's only 2 digits, but does 4 go into 75?
What?
Does 4 go into 75? Hell to the no. Right? No. 5? Yes. Ends in. Okay, I think I've done enough. I need to see this.
Yeah.
I need to see you apply the rule.
So that it sticks.
all of them?
Oh, look at that. Method to the madness. The more you write this shit down, the more it sticks in your head. Oh, Jeff has a purpose. Yes. I'm sorry, which one? Yes, exactly. Yes, but you better have a compartment there to show me this. Some of you guys were just dividing that by 2 and saying there's a remainder. No, that's not the divisibility rules. That's the calculator passes this class and goes on, and you take it again. Your little calculator goes and graduates, and you're all in the audience. Go, calculator. Sorry. Yes. Oh, hell no. I'm sorry. A real quick word about Scantron. If you ever have a math teacher that requests you have a Scantron for the test,
Drop it.
they are not a math teacher. I don't know what they are. They are not a math teacher. Because a math teacher is supposed to be looking at your work. That's why I gotta always see your work. That's my job. If you don't show it to me, I can't do my job.
It's my job.
My job. One of my 5 jobs. Alright. You guys, I'm sorry, I didn't mean to. Please don't feel bad about the way I reacted to you, but that drives me insane. And that would really give me, I would have so much time. Holy shit, I could do whatever the hell I wanted to. I'd be getting paid a decent amount of money for doing shit because I just feed it into the machine. The machine would think, that student got this. What good does that do me? What good does it do you to not let me see where you went wrong in your work and just go, you got the wrong answer, screw you. When it was just a little mistake you made, you know? I'm sorry, yeah, but that's why I don't do Scantrons.
Sweet.
Who did I skip over? Yes.
Can you solve the bonus question?
Oh, yeah, we looked at it.
You did like the little distributing part on the whole side.
What was the bonus question again?
No.
Oh yeah, okay. Sorry. So guys, a few people got sort of close. And again, now guys, I'll show you this. If you're not sure the steps I'm using, we haven't officially gotten here yet. We've only done like really basic equations, and I know a few of you guys know how to solve crazy equations. Again, great, enjoy it. But some of us are like, wait, this shouldn't say, I don't remember how the hell to do this. But obviously, hopefully, even if you're not sure what to do, where do your eyes go? What should I do first? Yeah, I must do this, so then I can get like terms together, right? So I get
What?
no minus 4. Because what am I multiplying 4 by? Everything in here. That's why it's in front of the whole thing. I like it. Then everything else is still there. The plus 2 equals 8 is just sitting there waiting. Alright, what can I put together on this side? Yeah, 4x minus 2. Bigger one's negative. Now where's my variable? What term is my variable in? 4x. How do I get this by itself? How do I get rid of the other stuff? Add 2. So you get 4x equals 10.
And then you divide by 4
Divide by 4.
on both sides.
10/4, which should be reduced to
Then what is 5?
5.
2.
Sure.
All that. Sorry. I feel like the old man. My day used to take us 8 pages worth of work to do one problem. While we're walking uphill both ways with no shoes on. Yes.
Okay, I'm having trouble with not like the word, but just like the word problems.
Okay. So somebody else was talking about word problems. I want you to understand we have not done any word problems yet. To be honest, no, we have not. We've done problems that have words in them, and I know that sounds like, picking it apart. Word problem is when you create your own equation. We haven't actually done that on our own yet. There's one set of problems that had you fill in this table, and the last entry had an X in it, and it's sort of like the way I did it in class. But we still haven't made a full equation and solved it from a given situation. There was a whole section with like the CDs, and there were 3 more classical than rock or something. So let me make a problem like that.
When it's small like that,
Sorry, buddy, hold on.
I did.
What is it, sorry? What about, what's wrong? Your glasses? Oh, they're not. What came off? Your glasses? Did they come off? What about your glasses? I'm sorry, buddy. This here? How's it supposed to be? I'm not sure.
Is it on both sides?
Yeah, it looks okay to me on both sides. Does it just feel loose? You look good, man. Can you see already? All right, guys, hold on. Have you read this yet? Bob makes $40 more a week than Fred. Shut up. Call Fred F. Right? So, how much does Fred make in a week?
$40 less than Bob.
No. Bob makes 40 more per week than Fred. So I can't do it both ways, but
We don't know how much.
call Fred's. All right, let me call Fred's salary per week. F. All right. How much does Fred make in a week? F. Bam.
We don't know how much.
I don't care. Yes, we do. F.
F. Right.
Yes. That's the thing about algebra. Just because I'm saying, yes, we know, it's F. I say it like that because now I can do something with it. If it's just the unknown, I can't do anything with empty space. I call it F so I can do shit with it. Now, how much does Bob make given this? How do you write that? Fred's plus 40. He makes 40 more than Fred does. So that's what algebra does for us. And unfortunately, when you're first learning algebra, the problems have to be sort of contrived. It's like somebody's got to know how much money they're making. And what the hell? These two people live next to each other. How much money do I make again? I know I make 40 more than them. Or later you get the guy that puts money into accounts in the bank and he forgot how much money he put in there. I'm like, I wish I had the problem.
Yeah.
I know how much money I put in the account. Not much. Right? So whatever Fred's salary is, what do you do to it to find Bob's salary? Add 40. That's what this captures. That's what an algebraic equation like this captures. If I knew this, I could then find this by doing this.
Yeah.
Yeah. So now if I knew what Fred's salary was, I could put it there and figure out what Bob's salary was. I like it. Now let me see if I can push this a little, just to show you where we're going.
Here we go.
What if I told you that Bob and Fred together make $1,000 a week?
We can solve it.
Divided.
If I said Bob and Fred together make $1,000 a week. How much money does Fred make in a week?
1,000.
That would be true if they made the same amount. Now again, how much money does Fred make in a week? F. Plus, how much money does Bob make in a week? And we know that has to be 1,000. So if I take Fred and I add Bob, I get 1,000. Now I can actually solve what Fred's salary is. I have to be given more information to solve it because I don't know what the hell Fred makes. But if you tell me together they make so much, I can then figure out how much Fred makes. That's a word problem. We're not there yet. If you're freaking out about this, okay, it's in our future. We're not there yet. It's not going to be on the test. I just wanted to push a little bit and show you what a real word problem looked like. So what we're doing is not quite word problems yet. It's just they give me a variable to represent something, and then it's like increased by 40 or 20 less. So then I would say something minus 20. That's all we're doing. We're not using them to create an equation yet. That's a word problem. Yes.
Can you please on the equation?
Maybe.
The 3c minus 6d. What they're problems?
Quiz, which one?
Quiz 2.
Quiz 2, number
D.
Oh, 1D. 1D.
Are we gonna have questions like that? Is that gonna be on the test?
This?
Anything like that?
Not yet.
Not yet. Okay.
Yeah. All right. So,
Doesn't have to be assumed.
of course not.
Of course it's like
All right.
What form of word terms?
Good. What are my like terms?
Nothing.
Now somehow people keep going. That makes me cry because I'm like, it's right. Why did you keep going? Is there any more A's anywhere?
No.
Any more M's?
No.
Any more single digit thing? No. So you consolidate all the different groups of stuff you've got. You stop. You stop. You can't make this become 15 something. But what's weird to me is I would think it'd be 15 a.m., but a lot of times people just throw 15a and just shove the m out of the way. Be gone with you. Right? So, but think about it. It's all I'm doing is consolidating what I can. I can put my A's together. How many freaking A's? Don't say 5A and 6A. Oh, you wouldn't say how old are you? You say, well, 20 years and then add 7 and then 8 more. No, just tell me the freaking number of years. So how many A's? Don't say I got 5 A's and 6. No, you got 11 freaking A's. All right, and 4 M's and then take away 2. That's what you got. Don't go further than that. Please. Okay. Cool. Okay, so that's what you do with that problem. And then where we want to go from there?
But can we explain, like, with multiplication and division and adding and subtraction, how negative numbers and positive numbers can be consolidated? So negative and negative numbers, like when multiplied, which is that?
Okay, we did some of that earlier, so I'm trying to. Do you mean just like a problem like this here?
Yeah. Or multiplication and division. Yep.
So okay, so like earlier, there are a lot of different ways to look at this, but I think the most straightforward is if the two things are the same sign. It's pretty cool with the fact that these are the same sign. You add them. So what's 7 plus 12?